Okay, section 2 here, we're going to talk about some real basic terms, terminology that we're going to use in this book. And then I'm going to introduce 3 different types of problems. And they're all kind of interesting problems, so hopefully you'll like them. Okay, the first thing we're going to do is talk about just some terminology that you've probably seen in past years, but I just want to quickly review it. A point is a location, so like this would be point A. The location. A line is made up of an infinite number of points going on forever in both directions. For example, this would be considered a line AB with an arrow going both directions above it. Same thing as line BA. They're identical, represent the same line. A plane is a two-dimensional figure. It's a flat surface, basically, represented by a parallelogram. A ray consists of an endpoint and then goes on forever in one direction. So if this is like D, like this would be ray CD. It cannot be ray DC. Hopefully you'll see why that makes sense, that would not be ray DC. A segment consists of 2 endpoints, like that, EF, and you can label this segment EF like that, or segment FE like that. It's the same, represents the same thing. An angle, okay, consists of 2 rays with a vertex. Go with like this. You can call this angle P. You could also call this angle MPN with the vertex at the center, or I can call this angle NPM with the vertex at the center of those 3 letters. If in doubt, use 3 letters. An acute angle is smaller than 90. Right angle is 90 degrees. Obtuse is between 90 and 180, less than 180. And a straight angle, of course, is 180 degrees. And this would be the vertex of the angle there. Okay. Let's jump to the first type of problem, which is talking about locus, not to be mistaken with locus. Not these types of, they are locuses. Okay. And a locus point is defined as a set of points that satisfy a given condition. Okay, and when we're talking about a locus, the solution for a locus is always going to be consists of 2 things. It's going to consist of a diagram and some sort of brief explanation as to what the diagram represents. Okay, so for the first one here, it says that, okay, what is the locus of points, or the set of points that are equidistant from 2 points? So if I have 2 points like this and this, the best way to approach a locus is to do 1 point at a time until you start figuring out what this figure is actually going to look like. So there's a point that is equidistant, the same distance from 2 points. Is that it? Well, actually I can pick a point right there. That would be the same distance from here as it is from here. I can pick another point here. another point here, another point here. Hopefully you can see that all these points along here are going to represent a line that sort of goes right through the center of that thing. That line, if I were to draw on this segment here, that line is called the, we already did this a little bit in one of the earlier sections, but it's called the perpendicular bisector. Okay, and so what I have drawn here is the diagram, and then the explanation as to what it is going to be the two things that are required when you're solving a locus problem. Next one here says, what's the locus of points that are 4 units from a segment? Okay, so if I draw a segment like this, and I give it 4 units away, okay, so 4 units up, let's use a different color to represent the actual locus. So the locus would consist of these points and these points. And then you have to kind of think about what it would look like over here. 4 units away, 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 like this. And you're going to end up with this pill looking thing. So all that in red would represent the locus, and so you can basically say it's 2 parallel lines that are 8 units apart, plus 2 semicircles on the ends. How about that? Okay, so something like that. Okay, so that is the idea for a locus right there. So next thing is, let's talk about intersection and union. Okay. Union is basically when you take all the points and combine the points together, combine the points. Intersection is when you look at which points are overlapping. So, take a look at this. This would be, you want to intersect segment AB, which is this segment right here, with segment BC, which is this one right here. And hopefully you can see that the intersection is just going to be this point down here, point B. Next one. I think this is supposed to be arrows at the end of these. Sorry about that. It's not real clear. But it's going to be ray EC, which is like that, in that direction, and ray EA like that. So if I combine it, or do the union of them, you're going to get line AC. Now you can call that many different ways. I can call it line EA, line AE, line EC, line CE. All those are the same. And all those would be acceptable answers. Okay, and the next one. Looks like I'm looking at the intersection of, I believe these are lines. Intersection of line AB, or AC, sorry, with line DB like this. And the intersection is just going to be point E. And let's jump to the next one. Next one is segment DC intersection with segment AB. And hopefully you can see that there is no intersection, so you have empty set, no solution. Next one is AC. I think it's supposed to be ray AC. So it goes on forever this way. And intersect it with ray EC, like this. So both of these are going on forever. And hopefully you can see that the intersection is going to be all the stuff that's like here. And it's just going to keep on going forever in that direction. And so my intersection is just going to be ray EC. And then the next one is going to be ray BA, ray BC. So BA is going to look like this. Ray BC is going to look like this. Hopefully you can see that that's just going to be an angle, right? Angle CBA. And you can hopefully see why I chose to use 3 letters there, because at this angle here, there's actually, you know, angle, if I said angle B, you wouldn't know if it's, is it this angle, is it this angle, is it the entire angle? Okay, an upside down smiley face. And then the last one here is going to be EC. Let's get my handy dandy eraser out. It's going to be segment EC, segment CB, and segment BE. So I'm going to end up with, hopefully you can see, it's a triangle ECB. You can also call it triangle EBC, CBE, CEB. There's 6 different ways I could call that triangle, but just need one of them. Okay, hopefully that makes sense. I'm going to flip over to the back side, and we're going to try the 3rd type of problem in this section. Okay. Okay, we're on the back side now. I skipped over some of the union intersection problems. You can try that on your own if you like. But now I'm at the bottom of the page looking at clock problems. So clock problems are, for me, one of my more favorite types of problems in this first unit. A lot of kids struggle with this, though, and they struggle mostly because they have trouble drawing the clocks. And you might chuckle a little bit, but it's true. I think the fact that most of your phones have, instead of hands of a clock, I think a lot of your phones have digital clocks. So here's what 3 o'clock looks like. That one's easy, right? What we're looking for here is we are looking for this angle measure that it makes. It's always going to be the smaller part of the angle, not the back side of it. And that one, of course, is just going to be 90 degrees. Pretty easy. Next one here is going to be 4:30. So kind of drawing this out. And it's going to be past the 4, so the little hand's going to be past the 4. The big hand's going to be at the 6. That's what 4:30 looks like. And then you have to ask yourself, okay, how much, if you're looking for this angle here, how much are each of these little 5-minute increments? Because there's 12 of those 5-minute increments, and there's 360 degrees all the way around the circle. So if I take 360 divided by 12, I'm going to get 30. So each of these is going to be degrees. And you know that this is how much of the way? Well, you know that the big hand has gone halfway around the circle, so I know that the little hand has gone halfway from the 4 to the 5. And so that means that this must be 15, which makes this 45 degrees. All right, pretty simple, right? All right, let's make it a little bit harder. So now I'm looking at 720. So I know it's going to be past the 7. How much past the 7 is the question. And then 20, of course, would look like right there. So that's 720. And so I can start kind of breaking this down a little bit. I know that this is going to be 30 here, this will be 30 here, this will be 30 here. And I know that this little hand is moving in this direction. And the question is, how much in that direction did it move? Well, it's kind of dependent on how much the big hand moved around the circle, right? Because the big hand moved 20/60ths of the way around the circle, or 1/3 of the way around the circle. And I'm going to multiply that, because this is going to be the same amount, same fraction of the way. It's going to be 1/3 of 30. Okay, or just 10. So this one right here would be 10, which makes this 720 100 degrees. All right, 145. Let's try 145. So it's going to be past the 1. It's going to be somewhere in the middle there, the little hand. 45 is going to be the big hand. And so I know that this is the angle I'm looking for. Right there. So I know that it's going to be 30, 60, 90, 120. I know it's got to be at least 120. Plus this fraction of the way around the circle. Of the fraction of the way from the 1 to the 2 here. Okay, and that same fraction is going to be the same fraction as 45 divided by 60. Or the same fraction of the way that the big hand is making its way around the entire clock. So times 30. Or it's going to be, what, 22.5, I believe. Okay, and so that's just going to be 22.5. So 145 is going to be 142.5. Then I'm going to throw one in here. Let's try 440. Let's do that first before we try 1104. 440 is going to be like this. If you want, you can go ahead and pause the video here and just try it on your own, but I'm going to try 440. And it's going to be, again, past the 4. It's going to be at the 40 right there. And so it's going to be 10, 20, 30, 60, 90. I know it's got to be at least 90. Plus, well, I know it's got to be the same fraction of the way around the circle, right? So it's going to be 40 over 60 divided by times 30, or equal to 20. So I just add 20 to the 90, right? Well, that's where you got to be careful. You should have been like, not right now. Remember, the little hand is moving this way, so that 20 actually represents that. The angle the piece of the angle you're looking for is actually this piece right there, which is actually going to be 10. So it's going to be 90 plus 10. All right, 1104. Let's jump back to the first one here. Let's try 1104. This is legit 4-level stuff here. Okay. So I know that 1104 is going to be little hand here, just past the 11, and I know it's going to be 4 minutes right there. So if each 5-minute increment is 30, how much is each of these little minutes here? Well, hopefully you can recognize that it's just going to be 30 divided by 5, or 6 degrees. So I know that this portion right there has to be 24 degrees. Now remember, the little hand is moving the fraction of the way of the big hand. So the big hand fraction is going to be 4 divided by 60 times 30. And that's going to give you how much the little hand has moved. So we know that this is going to be 2. So 2 degrees is going to be right here. But I know that in actuality, it's this piece right here I'm looking for. So that's going to be 28. So the answer is just going to be 52 degrees. Hopefully you got that. I'm going to stop here and let you try some problems on your own, okay? Take care.